Let's proceed to our next problem, which is yung sample problem number 2 natin. So we have a W18 by 50 beam with a yield stress of 345 megapascal is simply supported over a span of 6 meters. So we have a given length, which is 6 meters, and we have given distributed loads. The beam supports a uniformly distributed dead load of 20 kilonewton per meter. That includes the self-weight of the beam. So meaning to say, included na yung weight ng beam natin dun sa 20 kilonewton per meter. And we will just disregard this info dun sa properties ng W18 by 50. And a uniformly distributed live load of 27 kilonewton meter. So we have dead load and we have a live load na uniformly distributed. The beam is laterally braced at the supports and at the third points of the span. Determine if the beam is adequate for shear. So for this problem, we have an investigation problem. Kasi titingnan natin if our section is adequate to carry such loads as 20 kilonewton meter na dead load and a live load of 27 kilonewton per meter. So for this one, hahanapin natin yung value ng shear capacity ng section natin versus dun sa actual shear na ike-carry ng section natin. So as stated, we have a simply supported beam. So we have a simply supported beam here. Okay. So meron tayong given dito na WDL. So yung dead load natin, that is 20 kilonewton per meter. And yung W live load natin, which is equal to 27 kilonewton per meter. So which is actually loaded dito sa beam natin having a span of 6 meters. So it is already stated here na laterally brace yung beam natin at the supports. So sa support, brace yan. And at the same time, at the third points of the span. So for this one, no, hindi natin itatackle yung LTB kasi nga yung focus natin dito is yung shear stress. So, for us to know if the section is adequate or not, we need to solve first for the value of your shear capacity. So, para mahanap natin yung shear capacity natin, when we are dealing with ASD and LRFD method, kinukuha muna natin yung nominal strength na makakaya ng section natin. So, hanapin muna natin yung nominal shear strength, which is denoted by V sub n. So, as given by the formula, V sub n is equals to 0.6 F1 multiplied by the area of the web multiplied by the CV. So for this one, under sa nominal shear strength natin, so meron tayong mga factors and safety factors na ginagamit to solve for the allowable shear strength and the value of your design shear strength. So para malaman natin yung mga reduction factor natin and safety factor, so gagamitin natin yung nasa codes natin. For webs of rod eye shape members, we will going to check muna yung H over TW natin. So H all over TW. So for this one, para mahanap natin yung value ng H over TW natin, kunin muna natin yung value ng H natin. So that is the minus 2K design. So we have a total depth which is equal to 457. The complete properties of W18 by 15 nakalagay sa module natin. Minus 2 multiplied by K design. The value of your K design is 24.7. So the value of your H, that is equal to 407.6 mm. So makukuha natin yung H over TW natin. So we have 407.6 on over the thickness of the web na 9.02. So you will have a ratio which is equal to 45.19. And this one, yung nakuha nating ratio na to, we're going to compare that to 2.24 square root of E over Fy. So we have a value of our E na 200,000 megapascal. Yung Fy naman natin, ito yung nasa problem natin na 345. So we have a ratio which is equal to 53.93. So we will going to compare the two ratios caused by H over TW and 2.24 over square root of EFY. So for this one, so mapapansin naman natin, we have 45.19 and 53.93. So for this one, since less than yung H over TW natin, so therefore, kapag less than siya, the value of your shear reduction factor is 1.0. So this is for LRFD. And the value of your safety factor sa shear, that is equal to 1.5 under ASD. And the value of your CV, or yung web shear coefficient natin, that is equal to 1.0. So, nakuha na natin yung value ng CV natin. Kasi dito sa problem natin, we have already a given for the value of your Fy, which is 345. The value of your area of the web, so that is yung area ng web lang naman natin, and the value of your CV. Since complete na yung mga data natin, we can now solve for the value of your nominal shear strength. So the value of your nominal shear strength, we have 0.6. Fy is 345. AW, so gagamitin natin dito is yung total depth multiplied by the thickness of the web. So we have a total depth of 457 multiplied by the thickness of the web na 9.02 multiplied by CV, which is equal to 1.0. So the value of your nominal shear strength, that is equal to 853.28 kilonewton. So upon solving for the value of your shear strength, nominal shear strength, kunin na natin yung design shear strength and the allowable shear strength. So, unahin muna natin yung LRFT muna, or the design shear strength. So, para makuha natin yung VU, we just need to multiply yung VN natin by a reduction factor. So, for this one, yung reduction factor na gagamitin natin, that is equal to 1.0. So, we have a value of your VU, which is equal to 853.28 kilonewton. So, yan yung shear capacity ng section natin. So, for us to calculate kung adequate ba yung beam natin, we just need to compare this value to the actual load. So, hanapin natin yung value ng V actual natin dito. So for us to calculate for the value of your V actual, so hanapin natin yung V actual. Kunin muna natin yung value ng ultimate load natin or the ultimate distributed load natin. So for this one, since kailangan naka-factor yung mga loads natin, we have 1.2 dead load plus 1.6 live load. So for this one, we have a value of your dead load, which is given sa problem na 20. A live load naman, which is equal to 27. So we have a value of your WU, which is equal to 67.2 kilonewton per meter. So, para malaman natin yung V actual natin, yun yung V max natin. So, V actual, so that is equal to WL, L over 2. So, we have a value of your WU, which is equal to 67.2 multiplied by L. So, yung L natin, that is 6 meter. Since we have a semi-supported beam, kaya WU L over 2, yung formula in computing for the maximum shear, divided by 2. So, you will have a value of 201.6 kilonewton. So, if we will going to compare yung VU natin, we're going to compare VU and yung value ng V actual natin. So for this one, we have a value of VU na 853.28 kilonewton and the value of your V actual na 201.6 kilonewton. Since greater than yung capacity ng shear natin compared dun sa actual na nakaload sa kanya, meaning to say, adequate yung section natin to carry such loads. So, yung section natin is adequate for shear. So, next naman, we're going to check naman yung adequacy ng beam natin using ASD approach or using yung safety factor natin. So, let us calculate first for the value of your allowable shear strength, which is denoted by VA. So, yung VA natin, that is yung nominal. Divide lang natin yung safety factor natin. So, for this one, we have a shear factor, which is equal to 1.5. Yung nominal natin, that is 853.28. So, you will have a value of your allowable shear strength, which is equal to 568.85 kilonewton. So, for this one, kukunin din natin yung value ng V actual natin. So, same procedure lang tayo, no? We're going to calculate for the value of your total load. But by this time, yung gagamitin natin is yung service loads lang natin. So, we have WDL plus WLL. So, the value of your total load is now equal to 20 plus 27. So, you will have 47 kilonewton per meter. Next, we're going to calculate for the value of your V actual. So, that is WL over 2 or 47 multiplied by L. So, we have a value of L na 6 divided by 2. So, yung V actual natin, that is equal to 141 kilonewton. So, we just need to compare yung allowable versus the actual. So, we have VA. Compare natin yan sa V actual. So, the value of your VA is 568.85. The value of your V actual is 141. Since greater than yung allowable natin sa actual, we can now say na adequate yung section natin. So in designing beams, no, it is very important to check kung safe siya sa shear. So we have 3 criterias, no? 4 criterias pala. So una, dun sa bending, sa pag-check kung safe yung ating beam. Next naman is sa shear. Next is the deflection. And lastly, yung local failure natin, which is yung diniscuss ko sa inyo, no, lateral torsional buckling, compression flange local buckling, web crippling, etc. So for this one, sa pagde-design, kung nag-fail siya sa deflection, kaso safe siya sa 3, uulitin mo na naman siya. So as long as na ma-meet yung 4 na criteria, dun mo palang masasabi na safe yung beam natin. But for this example, we came to a conclusion na adequate yung section natin for shear.